Hello students, I am Shalaka Deshpande. In this today's session, I'm going to discuss about introduction to embedded systems. Okay, so see, the embedded systems are becoming very important part of our lives. Okay, they are used in our home, then they are used in the computer industry, and various other areas like telecommunication, networking, and industrial control applications. So they are becoming very inevitable and important part of our lives. There are various intelligent embedded players working behind making our life comfortable by working on the embedded systems, and it is a very interesting field. For example, it is used in your home also, and it is in home there are various examples of embedded systems like your microwave oven, your refrigerator, then air conditioning system, television, and DVD players. So these are the applications of embedded system. Now, why I'm telling applications? Because we should know why we are studying this subject and why it is important. So, if we know the application, we know the why we are studying the subject. Okay, okay. Now, here in this lecture, what are the learning objectives? We will see what embedded systems is. We will see the differentiation between the embedded systems and the general purpose operating systems. Okay, and then we will see the exceptions. We will also see the classification. So these are the learning objectives for today. Now let's get started. Your embedded system is an electromechanical device. It is an electromechanical device which is designed to perform a specific application. I'll write it on board. So I repeat, embedded system is an electromechanical device. It's a combination of a hardware plus software, which is nothing but a firmware used to perform a specific application. Okay, they are application specific devices. Why I'm calling embedded system application specific? Because they are designed to perform only that particular application. For example, your DVD player. Compare your DVD player with your air conditioner. The embedded unit in the DVD player is designed to perform only the showing pictures. Okay, whereas the embedded unit in our AC is designed to perform the cooling of air. You cannot exchange the embedded two embedded units. Okay, so they are application specific. Multiple applications are not applicable here. Okay, whereas we will now see the difference between the general purpose operating system and the embedded operating systems. Okay, now your example of a general purpose operating system is your laptop, PC, and these are your general purpose operating system. In the laptop or PC, you have the Pentium, Athlon, or AMD processor running inside it. Okay, and your laptop or PC you can use for various applications like sending email, working on a project, listening to song, playing movie. Now various applications are performed by single system. So that's why it is called the general purpose operating system. Whereas embedded systems, they are application specific. You cannot, if you design an embedded system for a particular application, you can only use it for that application. You cannot perform other tasks using the same system. So that distinguishes embedded system from the general purpose operating system. And next is the OS of the general purpose operating system. It uses the general purpose operating system. Now, operating system is a set of programs which make your hardware functional. Okay, it brings life into your hardware. Now, what is operating system and RTOS we will see as we will proceed further. Okay, now next is your embedded systems. Embedded systems may or may not contain an OS. There is not a compulsion that it has to contain an OS. There is a possibility it may not contain an OS. Okay. So this was the distinguishing point, and one more distinguishing point is that power saving modes are present in embedded system. It has lot of facilities to save the power, whereas in your general purpose operating system, power saving modes are not there. Power saving modes are not there. Very less facilities for saving the power. Okay. Now, as I already told you that they are general purpose in application, and it is application specific. For example, response time requirement is highly critical for mission critical embedded systems. Okay, in few embedded systems which are used in military, which are mission critical, where the response time requirement is very critical, we want the output within that particular deadline. For that, we are using hard real-time operating systems, embedded systems using hard embedded systems, I mean to say. There are two types of embedded systems, hard embedded systems and soft embedded systems. So in the mission critical embedded systems, the response time requirement is highly critical. We use hard embedded systems, okay, in the military applications. So this was the main difference between the general purpose operating system and your embedded systems. Now, there are some exceptions in the embedded system also which make this definition a bit wrong. For example, your multimedia mobile phone. It is the embedded device, but you can use the multimedia phone for various applications. You can use it for talking, you can use it for recording video, you can use it for messaging. So there are various applications of multimedia phone, but it is an embedded device unit. So it makes this definition wrong. But this definition is correct in most of the cases. Exception I have told you. Okay. Now there are various books related with embedded system, and different authors have different definitions for it. Some say it is a microcomputer used for performing a specific application. It has compared it with a microcomputer, and it's okay because processors are used even in the general purpose operating system. We are using the Intel or Pentium processor. Okay. Now we will see the generations of embedded systems. Means what? We are going to see the first embedded systems still and how they have evolved and become what they are today. Okay, so we have first generation. In the first generation of embedded systems, we are using an 8-bit processor or controller, 8085 Zalog 80. Okay, it is a very simple processor for first generation, and hardware and software for the first generation is also very simple. Okay, and as we move ahead to second generation, we will. For second generation of the embedded systems, we are using a core of 16-bit or 32-bit. Okay, now these microprocessor, microcontroller, ASIC, DSP, and FPGA, these are the cores of your embedded system. Okay, and for second generation, we are using the 16-bit and 32-bit processor. The instruction set of the second generation is more complex and powerful as compared to first generation. Okay, because we are using advanced processor in second generation. Now we will see the third generation. Now, for third generation of embedded systems, we are using 32-bit processor. Okay, as the processor got advanced, more advanced, we are using advanced processor in our embedded applications. Okay, now DSP and ASIC came into picture, digital signal processors. When you are going to design the embedded system for communication purpose or networking purpose, then you use a digital signal processors. Okay, and application specific integrated circuit. They are the chips which are very application specific. And in the VLSI chips, it consists of the four layer. Each VLSI chip consists of the four layer. There, the lower layer is ASIC, and the upper layer is a microprocessor or a microcontroller. So, ASIC is nothing but the application specific integrated circuit dedicated for a particular application. And concept of instruction pipelining came into picture. Now, why instruction pipelining? Because we want to increase the execution speed of our device. Okay, so instruction pipeline is used to increase the execution speed. Okay, and what is instruction pipelining? We will discuss in the further lecture. Now, next is the fourth generation. Now, in the fourth generation, system on chips and a multi-core processor came into picture. Now, system on chips means your core, microprocessors, peripherals, memory devices, and other components, supporting components, all on a single small chip. That is a system on chip. Means miniaturization and highly sophisticated embedded system, which are very compact and take a small size. Okay, multi-core means various CPUs in the parallel multi-core. So instead of single core, there are various processors inside your embedded system. So that is a multi-core. So these came into picture during the fourth generation. Okay, and they are very sophisticated, highly complex systems. Okay, which use a high-level language like embedded C for programming. Your multimedia phone is an example of the fourth generation embedded systems. Okay. Now, it is very complex. Your multimedia phone is very complex embedded systems. Okay, so that's why it comes under the fourth generation, the most advanced generation of embedded systems. So this was the introductory part for your embedded systems, and then we saw a difference between embedded system and general purpose computing system, and then we saw the your classification of embedded systems. So this was the introductory part. Thank you for watching.